In Dallas, it is common to experience occasional ice storms in which network shutdown happens and sites switch to backup power. However, it becomes unsafe for technicians to come and change the power settings in order to get sites running back up. Our proposed solution to this problem is to have a power controller that will be able to generate and selectively shut down certain technologies so that way sites can run on backup power for a longer amount of time. How we propose to do this is by implementing a 2-relay module box system that will be able to connect via Wi-Fi and be user selectable from the bottom so that technicians don't have to go up to the top and select which kinds of radios that they need to shut down. The way we're going to do this is presented in our design overview over here. We'll have a PC circuit board that will be able to control certain relays and be able to shut down technologies as well as other.
Yeah, so the circuit at the bottom, actually both circuits have a battery on them, and the battery, while the power is running on the station, the battery will be charging, and as soon as the power shuts down, our circuit will switch to being powered by the battery. And both at the top and the bottom have the same microcontroller that it communicate wirelessly, so the user can select their inputs at the bottom, and at the top it controls 12 different relays that each go to an antenna at the top of the cell tower. So the nominal power to power the whole cell tower is 48 volts. So when that power starts to drop at 2-volt increments, when it reaches like 46 volts, for example, it'll shut down one technology. So for example, maybe at 46 volts, it'll shut down LTE, and at 44 volts, it'll shut down 3G until the whole system shuts off completely at 40 volts. Now all of this is user selectable, so if the user decides they want to only shut down one technology and keep the remaining 3 running until we get down to 40 volts, that's a possibility. Additionally, it's going to wait about 30 seconds. So as soon as it hits that voltage threshold, it'll wait 30 seconds before turning off that technology. And then the user could program it to do it that way, depending on whatever they want to input into that box at the bottom. They could turn off technologies every 30 seconds or every 2 volts. But essentially, we are hoping that this will help conserve power on these cell towers when we have stations that technicians can't get to because of dangerous weather or because of other things that are going on. And so ideally, this will help to conserve that power and to hopefully keep communication active as long as possible. Thank you. Do you guys have any questions?
So, are you guys working with any network equipment manufacturers to?
We're not working with any particular, are you talking about companies? Yeah, not necessarily. However, Susan is doing an intern for T-Mobile, and it was kind of an idea that they kind of thought up. We're able to learn a lot of how these work in order to build this to be used for that purpose.
So the biggest question is, how are you guys going to be selectively turn off a particular technology? Today's the base stations have multiple technologies in the same box.
So the technician that we talked to at T-Mobile said that each technology usually had like 3 antennas, and each antenna would control high band, mid band, or low band. So we decided to just go with the simple relay system because he said that would be adequate, so the user could slow
That's certainly
it down.
true for the power amplification portion of it. But to my colleague's point, once you get past the power amplification point, if you go in and you look at equipment that comes from the providers of the equipment in there, when you ask them, okay, show me your LTE modems, they'll show you this box. You go, show me your 3G modem. They'll go, what's the same box? So have you looked at the actual implications of how much power you saved with this type of a solution? Because really all you're doing in those environments is shutting down, the high power transmitter, which is 4 watts, right? I mean, high power is a relative type thing, right? So the real question is, I get the idea, but the real power consumption isn't the power amplifier. It's all the electronics, which are common, because it's just software variation.
Yeah, I mean, we got the idea for this was specifically a T-Mobile technician's idea to just use relays to switch off certain antennas. So we'd have to go back and ask him for more details on that.
So
exactly.
basically, your system can turn off the power to antenna, not the technology itself.
Correct. Yes.
If we were to implement a system where we would be shutting off the antennas or the radios, that would be more software based. And that could be manageable, but it would be easier to actually implement that through their boxes that they already have, which would be their COVP.
Well, I
You would
certainly
have
agree
to-
that power management's an issue, particularly when you've got a extenuating circumstance that's in here. It's an interesting problem. I would just caution you that if you go forward with it, you might want to open the aperture a little bit more to understand the actual equipment implications as you drive it forward. And you might find that there are other areas where you can drive this solution that'll actually achieve measurable results in extending the usable time that you're not able to drive these things off of grid power.
And we have been looking into that. It really just depends on what we're able to get our hands on in terms of certain boxes and what's actually up there in terms of equipment, but usually based on certain technologies.
Well, this is a target-rich environment here, so go for it. I think it's a great idea. I caution you to open your aperture a little bit more as to the problem space.
Yeah, that was my concern, because you are getting into a too proprietary industry. Like, not one company talk with the other. They have a forum, everyone agree to a protocol, but they all implement it differently on their own backplane and circuit boards. So it's a real problem today, but it's not easy to solve it. There are many business implications involved in what you are trying to achieve here.
And that's why we're trying to make a generalized solution that would be applicable to other companies, not just T-Mobile. We're trying to make it to where it's more as
So
user
my point was,
selective.
T-Mobile is just an end user of what
Yeah.
you're trying to do. It's not about T-Mobile, it's about
Exactly.
Ericsson,
It's the NEP provider, yeah.
Nokia,
Yeah.
Siemens. Those guys
Yeah.
build these base stations.
But just to add to what you guys are doing, when you bring fiber optics to your home, whether you have FiOS or anything like that, those devices, typically a phone line is always powered from the central office, whereas in a fiber optics, you don't have power coming in from the central office. So if your power fails, that's why most of the ONTs, network terminals in your homes are powered by batteries. The chip design, we manufacture those. Those chip design itself provides me the capability, exactly what you're saying. I would turn off the TV first, then I turn off the internet, then I turn off the voice line. The last thing that goes off is the voice line, because that's the lifeline that you provide. And that is provided by the chip vendor. So as a manufacturer, I just have to program that stuff, right? So what you have is, yes, what you mentioned earlier is a software control, right? So you have the general idea of what to do. And then if you can find the chips, that what he's talking about, the LTE chip, these are all, again, a single chip can be converted into different things, and then they drive the different radios. And how you control those can be done that way, so.
Exactly.
One
One
more
more
I was
comment.
gonna say right quick, I kind of was remiss, this team and the following teams are senior design one. So they're, instead of being finished with their projects.
Yeah, I got that in
they're
there.
I think that's
halfway
where we are
through,
coming
y'all are in
to.
the position.
Like
That-
your
I think that's
intention
where
on
we are
some
coming
things,
to
yeah.
guide them for
Yeah.
senior design too.
Right.
So
Yeah.
if I were you, I would not pick this base station example. This is a pretty good concept. Go look into your home. Find what different things you are going to shut down. Like he gave an example, I would like to see that in your UTDesign too when I'm here next time. Because that could be a good usable solution for real world. Like base station, trust me, you are getting into a deep business problem.
My point is, power is a very important issue that sometimes doesn't get the attention it deserves. When we look at the TCO of some of this equipment, anywhere between 25 and 30% of the operational costs of some of the equipment in the networks that we're familiar with is power related. So anything that we can do that's in those areas, while it may not be the cool new sexy thing that the greatest next protocol will be, it's fundamentally important, because once you unplug it, if there's no juice, it doesn't work.
Thank you.